Okay, in this video we're going to talk about how you can use absolute values to write things in interval notation, or using absolute values and inner notation, how they're similar. So recall this definition of absolute value. Absolute value of A equals A if A is bigger than or equal to 0, and absolute value of A is negative A if A is less than 0. Sometimes we'll write it like this just to save ourselves some time. So we'll put a big squiggly bracket, and we'll say it's A if A is bigger than or equal to 0, and negative A if A is less than 0. So it's the same thing over here, just we save ourselves writing one absolute value of A. So we can use this definition to talk about intervals like this. So absolute value of x is less than 3. So what interval is this? So it's a little bit, we haven't seen anything like this, but this is just sort of certain values of x are true for this statement. So we have to figure out which values of x is the absolute value of x less than 3. And what we're going to do basically is convert it to interval notation. So let's think about the real number line. Now remember there's two cases, right? There's case 1 where the thing in the absolute value x is bigger than or equal to 0, where x is bigger than or equal to 0. And if x is bigger than or equal to 0, then the absolute value of x is just equal to x. So that would mean that absolute value of x less than 3 is the exact same, since x is positive, as x is less than 3. Okay, so for case 1 we have x is bigger than or equal to 0, so x is bigger than or equal to 0, which means we're dealing with positive numbers, so over here, but x must be, and x is less than 3. So 3 is here. So what interval contains x bigger than 0 and less than 3? Well, that would be all the numbers in this interval here. So right now we're going from 0 to 3. But there's also the possibility that x is a negative number. Remember, it's possible x could be less than 0. And if x is less than 0, then we're dealing with this situation here. So if x is less than 0, then this statement here, the absolute value of x less than 3, means absolute value of x, because x is less than 0, would be equal to negative x. So remember, we have to turn that negative number into a positive number. So you just need to solve this inequality for x, and there's different ways to do it. You could rearrange, add x to both sides, subtract 3 from both sides, or divide both sides by negative 1 to get rid of this negative. But remember, when you divide both sides of an inequality by a negative number, you have to switch the sign. So therefore, x is less than 0, right? That was our initial condition. And, 3 divided by negative 1 is negative 3. And x is bigger than negative 3. So negative 3 is over here. So we're in the interval less than 0, so that means over here, but bigger than 3, so that means over here. So the interval that we're talking about here is this interval here. So if you put these two cases together, we're going from negative 3 to 3. So therefore, the absolute value of x less than 3 means the same as these two intervals put together, right? This one and this one, which was from negative 3 to 3, means the same as negative 3 less than x less than positive 3. Okay. So that's important to know, and you could think about these two cases as to why that's true. We're going to see this is always true. Anytime it's less than, you can just take x between the positive one and the negative one. It's a little bit different when you're looking at an example where you're talking about, let's say, x, absolute value of x bigger than or equal to 2. So if absolute value of x is bigger than or equal to 2, again, you'd want to, well, I'll draw the number line here just to give us a visual of what's going on. But you're going to think about the two cases. So case 1 would be x bigger than or equal to 0. And case 2 would be x smaller than 0. Right, whatever's in the absolute value. So if x is bigger than or equal to 0, then absolute value of x bigger than or equal to 2. Because x is positive, that means absolute value of x is the same as x. So that means that x is bigger than or equal to 0, and bigger than or equal to 2. Well, when is x bigger than 0 and bigger than 2? That would mean that x has to be bigger than 2, right? Right? If the number was only 1, well, it's bigger than 0, but it wouldn't also be bigger than 2. So it has to be true for both of these two. So therefore, x is bigger than or equal to 2. In case 2, x is negative. That means x, absolute value of x, bigger than or equal to 2. Remember, now x is a negative number, so absolute value of x becomes negative x, bigger than or equal to 2. And if we want to solve for x, we divide both sides by negative 1. You have to reverse the sign. So 2 divided by negative 1 is negative 2, and x. So x is less than or equal to negative 2. So x is less than 0, and it's less than negative 2. Well, that's just the interval less than or equal to negative 2. So therefore, x is less than or equal to negative 2. So now you're going to put these two intervals together, right? So x could be bigger than 2, or it could be bigger than or equal to 2, or it could be less than or equal to 2. So therefore, absolute value of x bigger than or equal to 2 is the same as x bigger than or equal to 2, or x smaller than or equal to negative 2. So this interval, these two intervals, is the same as this interval over here. Here, I'll just write it in a, what do we call this? I guess interval notation. Sometimes we'd say x is an element of, so from negative infinity to negative 2, and we want to include 2. And then the way we say or is we put a union, a u, to infinity. So these are all the same thing, this one, and this one. So hopefully we can use those two examples now to answer similar questions, but more quickly. We won't have to write down all these cases. So if the absolute value of x is bigger than 5, so absolute value of x is bigger than 5, so that would be like this case where we had bigger than. So that's going to be the same as, so this is equivalent to x is bigger than 5, or x is smaller than negative 5, which is also equivalent to, if we wanted to write the interval notation, that'd be negative infinity to negative 5, and here we'll use a round bracket because we're doing strictly less than, union 5 to infinity. Okay. So if you're not really sure about why that is, go through the cases like we did in the question above, but hopefully you won't have to do that every time from now on. B, if we had one like this, absolute value of x is less than 1, let's say less than or equal to 1. Well, now, that's like the first case, right? where we had less than, and then we said it was between the two numbers. So absolute value of x less than 1 would be equivalent to um, x is less than or equal to 1, bigger than or equal to negative 1. Or if you wanted to do it in interval notation, you say x is an element of the number, the interval negative 1 to 1, square brackets because we're including negative 1 and 1. How about this one? Absolute value of x less than, what if it was a negative? What interval would that be true for? Well, if you think about it, this is not possible, right? Absolute value of x is always a positive number. Number cannot be less than 5. So this is not possible. Just be careful. You're going to see one like in your textbook like this. I think it was a mistake, but if the absolute value of something is less than a negative number, that's obviously not possible. So if you ever see that, something went wrong. Or just another example, what if you had the absolute value of x is equal to 2? Well, here there's two possibilities, right? X could be positive or x could be negative. So if x is positive, that would mean x equals 2. And if x is negative, that would mean negative x equals 2, which would mean x equals negative 2. So therefore, x is equal to plus or minus 2. So there's two answers to this one if it's an equal sign.